Hey everybody, want to do one last quick one. So far, we did a couple walkthroughs on how to kind of develop your program, this like your core stars that you're going to keep looking after year, pretty continuously, using resources like the section programs like the LPV program or the CV program, how to use VSX, where you can sort and find good data sets or a lot of stars. But sometimes you just want targets of opportunities, right? Something that's quick and easy and way to find potential targets without a lot of digging. And so I'm going to show you some other things that I haven't shown to you yet. One I use actually quite a bit, and that is the AAVSO circulars. So what is the circular? Let me share my screen. Every Friday, if you sign up for that, see, it's Friday, so I got mine. The AAVSO sends out an email. I subscribe to the LPV circular. There's 4 of them. This is the only one that I subscribe to. So I'll show you where to sign up. And what this tells you is every LPV that's been observed by somebody in the last 4 weeks. And so it's just a list of stars, and it's sorted by constellation. So here we go in say, I wanted to do something in Andromeda. I can kind of see some targets. These are probably vetted out. And it tells you a couple pieces of information, which helps you identify which ones you may want to go after or just disregard completely and move on. So the pieces of information it gives right here in the brackets, that's the star type. So here it's Myra, and SRA, Myra, SRA. Well, those are the easy ones. Those are what I would expect visual observers to observe. You got an SRB down here. It tells you this number right here, 155, that was the observation. So what this tells me, on June 27th, observer ZLT measured or observed EY in Andromedae at 15.5 magnitude. So that's too dim for me. So really what I can do is I can kind of scan through here. If I know, I can get a sense of where stars are now. Before, when I was looking through VSX, I was going to light curve generator to kind of get a sense of how bright that star was, especially if it had a large range like LPVs do. I need to know, is it in observable range for me? There's not a lot of value in just putting a less than observation in for something like an LPV. So I can kind of scan through. Now I can also tell, like, we've talked a lot about observing stars that have a lot of observers. I can see that here. So some of these, like EY and R and has 2 different people looking at it. RR and only 1. ST and there were a lot of observations. There's 1, 2, 3, 4, 5, 6, 7, 8 observations have been made by 3 different observers in the last 4 weeks. So maybe I do, or maybe I don't want to observe that because it's pretty well taken care of, or there may be some that there's a handful of observations, maybe it can benefit from more. So it gives you the date. That's what the number in the parentheses are. It gives you the magnitudes that were recorded, so you get a sense of how bright it was, or if it's in your range, and how many observers are observing it. So you can just kind of scan through, and these stars in Watis are very well observed. There's some good stars. So you can come in here and just do a quick scan. Like I said, if I don't have anything really prepared or not really ready, I'll just go to the circular and start picking out some stars and adding them to my list. So how do you get on this email? Good question. There's no real good place on the website. So if you go to the observing sections and you go to LPVs, because I said, hey, add this to the section, there is over here on the pages side, there's a link about the LPV circular. But it's a kind of a roundabout way to get this page, which I don't know how to find anywhere else. I just made sure it was linked to my observing section page. And if you want on there, you just email Elizabeth. Elizabeth's great, by the way. She's been around a long time. She's very knowledgeable. She's very nice. So if you send her, say I want, and tell her which circular you want to be on. We say here's the 4 AGN. That's active galactic nucleus. As a good side story is, yes, galaxies are variable stars because the prototype is BL Lacertae. I've observed it. This looks like a star, and it varies because it outbursts every now and then. And so we said, oh, it's a variable star, but we finally learned that it's actually an active galaxy, in which you're looking is not a star, but a galactic core that has, eruptions every now and then. So now we call it, we realize it's an AGN, but AGNs are variable stars. We have a section for them, high energy network. So if you're into CVs, LPVs, I'm surprised they have an RCB one. There really aren't that many RCBs out there. They're extremely rare and they're extremely cool. I recommend them, but it's just as easy to, there's only a handful of them. Look them up in VSX. If you search by RCB, you will not get many things out there. So that's one way. A little deeper, you probably won't find a lot of good targets this way, but just be aware of it. Is the alert notices. I know a lot of people who, it's always fun to be on a campaign. A lot of them have very specific requirements and are usually geared towards photometrists. If you're on the distribution list, you'll get the emails for when these come out. But if you ever, now I got to remember where they are. Submit and access data, I think. Bear with me, maybe I didn't think this out. Yes, I did. Okay, so you come to, back up. Submit and access data, go to the research portal, and you will find alert and special notices. This gives you all the campaigns. This is when a researcher comes to the AAVSO and says, I want this specific thing. He's like, can your observers do this? And they'll give a write-up of what they want, what they need. I've participated in a few, so it's cool if I can get there. Here's a good long running one with an LPV of our Aquarii, and it's coming up. This is an extremely interesting star. There's been several alert notices on this one. So if you click on the alert notice, it will give you more information about what they're looking for and what to do. So if you're really keen on that kind of thing, you can kind of scan through here and find some stuff if you so choose. So that is that. Now I mentioned in the forums, when we're talking about photometry versus visual and who's better and dissuade some of the things, but just to put some more backup to the things that I was saying when I mentioned I had 2 anecdotes and I started to type them and decided I didn't want to type them. But I think it was in 2018, there was a paper by Bodie. And what Bodie was doing was they were looking at the Kepler data. And they were studying specifically RV tau stars. Very rare, very evolved star, LPVs. And they used there was one RV tau type star in the Kepler field. Remember the Kepler field, Kepler just looked at one little patch of sky in Cygnus, and they wanted to do a statistical study. So they're like, we'll figure out every type of exoplanet we can find in this little patch of sky, and then we can extrapolate that out across the whole sky to get an idea of how many exoplanets might be out there. But it observed other things too, because it was looking at everything in this patch of sky. So all that data is just out there, and anyone can use it. So this group was like, we're studying RP taus. Kepler gave intense, highly precise, highly accurate photometry for a 4-year period. So if you're studying RV-TAOs, there's 4 years of excellent data from this space telescope. So they used it. What they also did was took all the visual data they had from the AAVSO, because this one RV-TAO star, DF Cygni, was a very well observed star, and there was a lot of data in the database. So they took that data set. Why wouldn't they? One of the things that they started to do, since they had these two data sets, is they wanted to compare them. They wanted to see how good this AAVSO data was, how, since it was much longer in time, how does it compare to this, super precise billion-dollar piece of machinery in space? Well, when they started analyzing all of it, they found that the photometry from Kepler was no good, or was no worse or no better than the AAVSO visual data. When it came down, when they started doing the statistical analysis, they started doing bend average on all these visual observations. They're like, we can't say one is better than the other. Does that not blow your freaking mind that this telescope in space can produce data at the same quality as some dudes in their backyard with something, with a Celestron or a Orion telescope? That's the power of good visual observers. Now, there are, they analyze it, kind of some of the keys. Now, not every star is going to produce visual data as good as we did with DF Cygni. DF Cygni has some things going for it, and why it was so, that data quality was so good. Mainly, it had very good comps. So if, we always say, when you're looking at your charts and you find comp stars, you want to beat your upper limit and your lower limit within a magnitude. Not always possible, but this star had a lot of different comp stars kind of in the range that it normally existed. So you could get very good comps, you could get very tight on your measurements. It was also very well observed. And so, as I mentioned in some of the forums, there is critical mass, more observations, and you average out, then you start getting rid of things. And it also had not just a lot of observations, but it was a lot of different observers, which makes the data better. It is better to have a lot of people observing more sporadically than just like one or two people who intensely observe it, because then you can get rid of observer biases and its position on things. There was a lot of good stuff going for it, but it is possible in the right circumstances that you can get very quality visual data, and this was the case. Just to take it on the other side, I'm not trying to just hate on photometry and say, oh, visuals is the mecca of all mecca. I'm just saying, don't discount it, or don't let people tell you that it's no good and it's not worthwhile, because it certainly is. And hey, some of my best friends are photometrists. I do plenty myself. Here's a good example of things gone awry. Is what I was mentioning on the forums is, yes, we're talking about accuracy, but in precision, and the differences between the two. Here's a data set. Let me share my screen again. So I got an email a couple of months ago. As I mentioned, I've been doing a study on a star, VN CVN or VCVN. Very, very interesting star in Canis Centaurus, and for this German researcher. And we're doing multiband, multiband photometry, BVR and I. And he's also got an observer in England, also doing BVR and I. And our stuff is very much meshing, like except for an I band. For whatever reason, he emails me and he's like, I'm looking at yours, I'm looking at mine. We are 0.3 of a magnitude different on I band. So that's very significant. And let me share real quick. And I mean, it's incredibly obvious. And so both of our data sets are very precise, but they are very inaccurate. So here's, these blue dots are my I-band data. Here's his. So he's 0.3 of a magnitude higher than mine. And so we start questioning, how could this be? He mentioned he's not transforming his data where I am, but that shouldn't cause that big of a difference. I'm like, that might get us somewhere in the the 20, 30 milli, that might account for somewhere in 20, 30 millimags, not 300 millimags. And so I went back, actually I should have kept staring at my screen, and I started examining my comps. And, as I went through and started, you start spreadsheeting it out, and like, okay, here's my, here's the data for my star, here's my check star. And I see, my check star and I should be at 7.56. Here's all mine. And I started, running the SDOMs on it, started seeing the averages. And yeah, sure enough, I was part of the way there. And, I did all this now and said, I am consistently, my data is super precise within 15 millimags precision, but I'm consistently dim by like almost 0.12 magnitudes. So something was off. I still have to go and dig a little further to see why that is. I don't get that in all my other bands, but I'm getting it in I. I don't know if it's a transform issue with my coefficients. I should actually look at that. Or, we started examining our sequences, but at the same time, I'm like, that closes the gap. We're looking at 0.3 of a gap. I can say I'm off. I'm off by, 0.12. I was like, you need to look at yours as well. He hasn't really done so, because I'm like, I think what's happening is I'm consistently too dim and he's consistently too bright, although he hasn't gone back with his data and confirmed it yet. So you can't be like, just don't, like you said, you just can't accept because it's photometry, it has to be right. No, it does not have to just be right. You got to look at it. And even when you're doing a lot, it just takes some time to go through all these things and really validate yourself. So those were my two anecdotes when it comes to visual and photometry that I didn't feel like typing up, because I typed a lot. So that's all I got for today. But yeah, sign up for the circulars. They're great. I use them all the time. And catch you all later. Bye.